Hello everyone. I think I didn't notice that we started already. All right. It's May the 10th, so I decided to do it early in the day, so my brain is better functioning. All right. Let's take a look at what we have today. I think this one's broken. See, it's always showing the same thing. Oh, it's just that minimal window stuff. Is that people constantly doing this problem? All right. Anyway, let's take a look. Counting primes. Count the number of primes less than a non-negative. Okay. 5 times 10 to the 6th. Uh, oh my god, I have 8 hints. I mean, we can use the Eratosthenes sieve. I haven't coded for a long time, so I'm not sure how that's going. I used to be able to do it very fast to get all the primes, right? I mean, you can Google it. You can Google the primes below 5 times 10 to the 6. Right? I can solve it that way. Or let's do the sieve. Yeah, let's do the sieve. I mean, we haven't done the sieve for a long time, so. Oh man, let me think. So sieve, we first create n. I mean, what we can do is using cache. We just create until the maximum, and then we just count. Well, that's possible. Yeah, I can do that. So how do we do the sieve? But 5 times 10 to the 6th. If we do it once, that's what? That's a lot. We might time out if we want to do it. Well, we can keep on building the sieve. That sounds right. That's an interesting thought, because we have to do it many times, right? We don't know how many times they can call. So if we can build, like the n will be 5 times 10 to the 6th. We might also hit a memory. A memory, I don't know. Will we hit a memory? We're gonna try. Times what? 10, 5 times 10 to the what? 6. Let's return anything. Let's see if we will have any timeout in terms of. Oh, okay. Okay, that's fine. I guess it's fine. Okay. How about we iterate through it? Oh, it's not iterate through it. You have to iterate many times. But if we do a sieve, you have to iterate through it many times. So, do something. Just do something. Okay, and then see if it times out. I'll at least know. Oh, look at this. 224 to iterate through it once. But I think if you want to do a sieve, that's going to be O(n) squared. And the O(n) squared is going to time out. All right. For each individual, it might time out. So we create a sieve on in each instance. Oh man, I can create an instance on each instance. Let's do the sieve. I forgot. So we cross out all the 2's, right? And then we go 3 and all odd numbers, right? We can do 3 and then 3 times 3, 3 times 5, right? And then sum of 5, and we do 5 times 5, 5 times, and we go all the way until the largest divided by it. Yeah. So we go, when do we end? What's the end? The end will happen with square root. Square root. All right, let's not consider this the catch. Just do it the most generic way. The most generic way in terms of sieve. I used to do the sieve like when I was working on the Euler project. That was a long time ago. And because there are a lot of prime related problems and you need to create a prime, a series of prime numbers. And then sieving is like the go-to methods. I think it's n+1, right? And then hold on. So what do? We are going to, if it's a prime, we are going to not change it. If it's not a prime, we're going to change it into 1, right? So we're going to say sieve 0 is going to be 1, because 0 is not a prime, and the sieve 1 is going to be 1. These are not. Then I'm going to do one round just for the odd numbers. I'm going to for I in range from 2. Actually not. 2 is going to be 0. Wait, change it back later. Hold on. 2 times 2. I'm going to start from 4. 4 to n+1, right? And then there's all the even numbers. And then we're going to say sieve I equals to 1. So these are all bad. And then we're going to start for I in range. It's going to be 3 to what? SQRT. So we need import math. We need math. Right? So we're going to go to int SQRT n, right? Yeah, and then just make sure, so we're always +1, and we're gonna do 2, so it's gonna be all odd numbers, right? Then what do we do? I mean, I itself is, and then for j range, j equals I, right? While I times j is smaller than n, smaller or equal to n, then we say sieve I times j equal to 1, right? And then we go 3, and we have to increment j. So j plus equals to 2. So it's going to also be all odd numbers. After this is done, then we can count. We can just say return sieve dot count. Do we have a count? Oh, we have count. Count number of zeros, right? Count number of zeros. And let's try it. I haven't done this for a while, so might not be correct. But we're gonna try. So 10, gonna give us 4, and 0 gonna give us 0, and 1 gonna give us also 0, right? So this is going to be n. This is going to be dot count primes. This is n. SQRT is not defined because I forgot to say math.SQRT. List assignment index out of range. Oh. Huh. That is true. That is true. Oh wow. Do not All right, so what we can say, no, this is not gonna work. So we have to go from 2, right? And then after that, we just say sieve 2 equals 0. So has to be, this requires to be 2, right? Which means if it's smaller than 2, we're gonna handle it ourselves. So sieve is gonna be this, and then I'm gonna say 0, 1 is 0 is 0, 1 is 0, right? And 2 is fine. We can do, and so we're gonna just say if n is smaller or equal to 1, we're gonna return 0, right? So we don't have to worry about that. And then we can handle everything else. Let's just see how much. I mean, it's gonna take what? I mean, it's gonna take 200 something to handle, like, what? What's the 50,000? 50. No, not 50,000. 5 times 10 to the 6. 6 zeros. Need time out. How long is it gonna take? Oh, Lord. It'll take 1 second. I'm gonna try it. I'm waiting my timeout. If it's timeout, I'll have to cache it if it's timeout. I'm not sure. Ugh, we got a wrong answer. That is surprising. What, 3? 2. Oh, less than. Shoot. Less than. Less than. So it has to be n. Okay, that's my bad. Has to be n. Right? N is 2. Then, less than, it can be like this. And this range is going to be to n, because it's less than n, not less than equal to. Everything should be the same. Yeah, if it's less than n, it's going to be 0. And it has to be 3. What if n is 3? Well, 0, 1, 2, right? And 3, well, we'd also do plus 1. We cannot do because this is already out. Wow, I didn't realize. So 2 is going to be 0. 3 is going to be 1. 4 is going to be 2. 5 is going to be 2. 6 is going to be 3, right? 2, 3, 5. Now 10, how did I get to 5? Uh, 10. That was correct earlier. 10. 2 to 10. But we don't consider 10 because it has to be less than 10, right? So 2, 4, 6. How is it possible that the count will be actually more? We are restricting. I don't know. So 0, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 9, right? First 2 is 1, and from 2, 0, 1, 2, 4, 6, wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I got one more. Okay. So that's that. And then from 3, what we're going to do is I times j, right? Just 3 times 3 is 9. That's going to be a 1. Okay, j plus equal to 2, and then 5. And, oh, I think this should be smaller here as well. And so do we solve it? No. So next one, I is going to be 5, but sqrt n is 10. 10 will be 3. Oh, here. This is the problem. Huh, so sqrt, I do have the plus 1. If we do plus 1, then sqrt, what if it's a square number? If it's a square number, and then which means we can reach the square number, but it should be fine. Yeah, it's fine. Because a square number is never a prime. Yeah, okay. That should work. Okay, that is unexpected. I'm gonna try it again. Pending. Oh, yeah, it's accepted, but I'm not sure about the runtime. Ooh, 2000. Sure, it's gonna be 2000. Because I'm using the sieve. Alright, so using Tosthenes, I think that's how you spell it. Sieve. Directly. Directly. But keep in mind that the requirement is smaller than n, right? It's smaller than n, not smaller or equal to n. All right, we're gonna try the other methods, which is like do it once. So we probably will end up, because I think it's a 1,000, right? 1,000-ish. So we're gonna try the other method, which is cache it. Let's cache it. Cache it. Cache the sieve. The sieve. So we're gonna say primes is going to be this, right? And then we say if not primes, then we're gonna do the sieve. Sieve. How do we do it? We don't care any of this. The largest is going to be 5 times 10 to the 6. So we just do this. Boom, boom, boom. After we've done it, I'm going to say for S in sieve. Nope. For IS in enumerate sieve. If s equal to 0, then primes dot append self dot primes dot append I, right? So now we get it. Then we just need from bisect, import bisect. I think we can do bisect right. Then we can just return bisect right self dot primes n. Right, I think that should be correct. Primes not defined. Okay, it's self dot primes. Why bicycle right is not correct? It's always bigger. I'm doing bisect right? So it's always on the right side. If it's always on the right side, and I mean then we have the issue of including or not including. Dang it. If we say it's here, like 0, 1, 2, and then we go to 3. How is this? How do you figure? Alright, let's take a look at the first one. Why the bisect is not going to work? That's not a good idea, I suppose. No, it's not a good idea. But these are all the primes. So we just need to do the first 10. We don't have to do all of them. Are they about to stop? Can I stop it? I have to. Yeah, this happens sometimes. Let me go to my here activity monitor. I can't even see it. Here we go. I close. Quit. Come on, quit. Oh, did I even save it? Oh yeah, it is saved. There we go. This should be easier. There, okay. How is it? Oh, what is this? 10? Oh, shoot. Dang it. That's why. Max and I was like, why is it not working? Because it has to be max and same thing here. Has to be max and same thing like here. Max n. We should have to add another one. And this is also max n. Yep. That should be right. There you go. I'll take a little bit longer. 2 seconds. 2 seconds. I think we'll be taking the same time overall. We'll see. We'll see. Try this method. This is a cache. Let's see how long it's going to take. Yeah, it's 2 seconds as well. But I think overall, no, it's going to take 2 seconds. So overall, it's going to take 2 seconds as well. So no, I don't think it's going to be any faster. Oh, oh yes, I forgot about that. Oh man. Bisect left. Yeah, bisect left. It's not right. Come on, man. It's bisect left. Okay, I don't think this one is any faster. This one should be the same, and even slower. Yeah, it's about the same. Maybe it is faster. Huh. Okay, I actually don't know the time. Alright, let's also do the cheating method. Alright, so this is count, this we'll do sieve. And now I really want to print. But I don't think it's going to be that much because, yeah, that's it. That's all the numbers. So we are just going to cheat it, right? C, and then we say class solution 3 primes equals this, right? And Yeah, it's always nice to use the cheating method. So this is cheating. And then return directly. Yeah, so return directly. I mean, since the memory can hold, right? If the memory can hold, is this even cheating? I mean, it is cheating if you look it up yourself, right? But we're not. This is going to be very fast. Blazing fast. Oh my god. Oh my lord, this is the most interesting solution ever. All right. Let's see. I say we can we even run it? What even complain? Ha! You cannot do it that way. You cannot do it that way. It says your code is too long. All right, then this is not working. That's fine. That's fine. Let's go to the solution and also come in here. Oh yeah, it's actually faster. It's actually faster. All right, so this one, what's the runtime? Runtime is on, right? On square root n, right? Because this is on, and this is square root n. So on square root n, and this is on. This is on square root n, right? So this one, actually, no, this is also not on because we are starting from a pretty large value. So it's actually n divided by, yeah, let's just call it, I don't know. This causes this milliseconds, right? Which gives us, that's a 27% ranking. 7% ranking, right? And this is, we're gonna cache the C. All right, let's not do this. It's just eating away my memory. It's just ridiculous. That's how slow it responds. There we go. It's eating away my memory. This one, cache, we get 1684 milliseconds, which is, I think, 30 something percent? Yeah, 32%. All right, let's see if there's any more genius way. Or maybe there's a mathematical solution. I don't know. Is that a medium question? That's an easy question. That's an easy question. Like, it's not going to time out if you... I don't know. Maybe it won't. But I still got it. the C. Still got the C. Let's see. Oh. Oh, log n, overall time complexity. I think it's just they're actually trying to do it that way. Did I spell it right? Eratosthenes. I spelled it right. Okay, I just read the code directly. So numbers for p in range 2 to square root, if p not in numbers, numbers multiple equals 1. So this is all the values, 2, 3, 4, up until square root. And if we have not counted for multiples in range p times p, so this is to count all the multiples of p, right? P, oh, which is, oh, it's the same thing. This is to find all the, oh, in that case, is it? We're doing p times each time, right? But here, we're doing odd numbers. Can we do better? Can we do like j plus equal to I? Hold on, let me think. So we have a value, right? And then every time this times this, and then this has to time an even number because we have not considered the even number yet. That's why we have to j plus equal to 2, right? That's why we do j plus equal to 2, because all the odd numbers has been considered already. I think the overall time might be the same. All right, so which is, if p is not in numbers, we just take all the multiples of p times p, and then p times 2p, p times 3p, 4p, 5p, p times p. And then, oh no, that's plus p. That's plus p, is p times 2p, p times 3p, p times 4p. Which is same, this is I times I, right? I times I times, that's not 2I though. It's p times p, p times p times 2, p times p times 3. Is this the same solution though? 2 times 2, right? 2 times 2, then 2 times 2 to n with 2. So that's all the even. And then we go to 3. So 3 times 3 with, so it's been 9, and 9 to n with 3. So we'll go 9, 12, 15. Right? If it's 5, it'll be 25, 30, 35. Yeah, I think this is counting multiples. All right, this is counting multiples because it does not skip. It does not skip the even numbers. So we do 2, we already got all the even numbers. But then we do another one, they do it again, all the even numbers. We hit it again. I think this is actually slower, but it looks like it's better. Oh, but we have a p not in numbers. So if p not in numbers, so we don't consider it. With p in the numbers, and we don't consider. So if it goes 3, we do it. 4, it's not already in, so we don't do 4, and we do 5. But if we do 5, we still consider the things that we don't have to. But we do have to do a n first. But that's on plus this. This is square root n, so it's the inside. Yeah, so the inside definitely is not n. You don't do it n times for the inside. So we can do this, right? Well, how many times we have to run, right? So we start with 3. We actually analyze it. We start with 3 times 3, and then is 3 times what? 3 plus 2, 3 times 3 plus 4, right? All the way to the end. So how many times will we have to do it until we reach, so it's n divided by 3. N divided by 3 times, but it's n divided by 3 divided by 2 times for this. So it's going to be plus n divided by 5 plus 2n divided by square root n, right? So yes, that's true. So we're going to have to add them together. This is bounded by the proof is available here. I probably don't want to go. Let's click it. Okay, let's also go to the discussion for sure. How do you use the sieve to get it so fast? What is this? Ah. To do this, if strikes I is not equal to 0, then we do strikes I times very slow 3 times faster. Total number of indices for n. Shift to get number of slots in range of interest. Get number of groups. Get number of slots. This is splicing. Oh, we use splicing directly. We need to improve our understanding of this. Okay, so we directly go. That's actually fine. We just do one round, and we only consider when it's not 0. I mean, for us, we can do it both ways. And let's understand this. So this means from this, oh, that's the same thing. From this, we're gonna go n, this to n, with this. That's the same as here, and equals. Is that a copy? Wait, these are splicing. That's a copy, right? But I guess it's not a copy then. Really? It's not a copy? Well, when you I know when you pass to the function, it's a copy. All right, let's try this. So this is our here. If I say a 2 to the n, no, let's say 1 to the n is this. If I say this equals to 0 and 0, what do we get? Ah, it is not a copy. But if we say def full some list, and then b0, let's say, equals to 1, right? And then we say a is this. And then if we say full a 1, I think that's a copy. And then we do a. Yep. So you pass a list. You pass a spliced list. That is a copy. But if you don't pass it, you run it directly, and that's not a copy. Okay? This makes sense. This makes sense. How about this? What is this? So basically, this will get out all the spots, right? We get all the spots out, and then they all become 0, right? Then we need to know how many there are, right? How many there are. So the numbers are n minus 1 minus I times I. So it's n minus I times I. That's the first one. That's the first one, first item. This is the last item because we cannot reach n, right? So it's the last item minus first item divided by this plus 1. Oh, yeah. Oh, wow. Oh, kudos to you, sir. Would it be slower? Yeah, this is, you are passing, then you're doing copy now. Yeah, you're passing it. But you do this, that's not a copy. That's, I think, is that's just a reference. That is just a reference. But if you're passing it into a function, that becomes a copy. I think that is the thing. Good lord, that's a new way of doing the sieve. It's the same. I mean, the official solution is a sieve as well, but this is definitely a much, much better sieve. To learn the new way, they're stuck with the old way of thinking. Basically means these two can be combined, right? That's the idea. All right, let's do this. Here. No. We're gonna go to the front, then V, go to the end, then we're gonna yank it. We'll go to 60. We'll paste it, and then we'll add a new line, right? So what I say is gonna be sieve, right? It's going to be, yeah, let's do 1 times. 1 is, and then we cross out, yeah, that's a better way of doing it, right? And then we do immediately. We say for, no. So sieve 0 and sieve 1, these are 0 and 0. So these do not work. Plus, if I is smaller equal to 2, I return 0. Yes, that's the requirement to start with, right? And then we can say for I in range 2 to int sqrt_n plus 1, right? And if sieve I is equal to 0, no. If sieve I, which means it's not checked yet, then we need to check it. So the sieve, how do we check it? We say sieve from I times I, right, until n with I step. With I step. Which means we take all the multiples of I. Multiple 1s, 2's, 3, yeah, all the multiples of I. That is going to be 0 times last element minus first element divided by the difference plus 1. Yeah, that's the Gauss formula. What the heck are you doing, man? It's the Gauss formula. And when the return, we can just sum sieve. I do SQRT again. Massive SQRT. There we go. Very good. Very nice. Indentation is not a multiple of 4. Same sieve, but much nicer and simpler to implement. So, no. What is the one? This one. I like this explanation. Should also say it is also the same as the official solution. All right, let's check. Is it going to be faster? 1, 2, 3, 4, 5, 6. And I think run like 2 seconds. Oh wow! Wow, splicing is fast. Wow, splicing is fast. Jeez. And oh, this is to find. Anyway, so note. Let's say note from the official solution. The runtime is bounded by O SQRTN, so I think we'll go to a new line, times log n. All right, that's it. It's very nice, very nice. I also write like the runtime. Splicing is fast. Runtime is 316 milliseconds. Wow, it shaves so much off. 4 times faster. Oof. With a 90% ranking. All right, that's pretty good. Pretty good. All right, I think I'm gonna go take a closer look at this paper, just to figure out if I can understand the bounding of the runtime. But that will be it. That will be it for today. I'll see you guys tomorrow. Adios.